All right. All right. So the next portion of the class that I want to cover is the organic nomenclature, or how to name this particular molecule. I already asked you from the beginning to memorize the name of carbon chain molecules from 1 to 10, so methane, ethane, all the way to decane. And on the previous videos as well, I've already asked you to memorize the different kinds of the functional groups that we have. So an alkane is all single bonded molecule. An alkene, oops, my video is going all over the place there. Sorry. An alkene is double bonded, alkyne triple bond. Haloalkane is when you have halogens on it, ketone, aldehyde, esters, and so on. We didn't cover thiols, but that's all right. So these are some of the most common ones, and I already asked you to memorize some of these as well. Now, we're going to do a little bit of an informal one, and then we're going to go into more formal one in terms of how to name a structure. The particular naming structure that we're going to learn is the IUPAC nomenclature. So IUPAC is a short for International Union of Pure and Applied Chemistry. And essentially, it's one of them is established that so we can have a very standardized name, molecular weight, and atoms, and so on, internationally. And one of the things that it establishes a name on how to name organic molecule. And the purpose is pretty straightforward. That is, if you know the name of a particular molecule with some training, you should be able to easily convert it to a structure, and also vice versa. If you know the structure, if you can draw them, you should be able to then convert it into a name, and there shouldn't be any confusion between how to translate between one to the other. There's actually, the rule is actually kind of long, and I will go through them, or the majority of them, later. But we're just going to learn some of the easier one first. So an example molecule would be something like this. We can have a molecule that's called a penta 1,5-diamine. So the first one here is a penta. It tells us that the longest carbon chain is 5. And then it's also have a name, an amine. And specifically, there's a di. And you remember from our chemical name before, a di is a prefix for 2. So specifically, this molecule have 2 amine functional groups. Right? So 2 amines. And where are they located? Well, the 2 amines are located in position number 1 as well as position number 5. So let's try to translate this whole thing into an actual structure. Right? Because again, the purpose is for you to be able to convert the name into a structure. So this is the name. Penta, the longest carbon chain is 5. So I'm going to draw 1, 2, 3, 4, 5. So I'm just going to label it 1, 2, 3, 4, 5. So I have 5 carbon chain long. And in position number 1 and 5, I have 2 amine functional groups. So I'm going to use a different color. In position 1 and 5, I have amines. So NH2, NH2. There. See, it's pretty straightforward now. Once you kind of understand a little bit of the trick, converting the name into structure is no big deal whatsoever. We're actually going to have a harder challenge converting a structure into a name, but for now, hopefully you can see that this is pretty straightforward. Let's do some more example, and we're just going to add the level of complexity as we go. All right, so the next structure that I want you to try to do, again, the best way to go is just pause and then compare your answer to me as well, to mine as well. The next one here is a 1,4 butane diol, or it can also be written in terms of the IUPAC nomenclature as a butane 1,4 diol. So let's try to translate this whole thing. So the first one is a butane, that means the carbon chain is going to be 4 carbon chain long. And I have a di, I have 2 of something here. 2. Now the question is, what is this prefix, or sorry, a suffix of OL? What is an OL? What is a functional group that have an OL at the name? And you'll find that this is going to be an alcohol. So essentially, this butanediol or butane 1,4-diol is a 4 carbon chain long molecule that have 2 alcohol functional group in position number 1 and position number 4. So let's try to draw this as well. So we have 4 carbon chain long, so 1, 2, 3, 4. 1, 2, 3, 4. And position number 1 and 4, I have alcohol groups. So position 1, I have OH, and position number 4, I have an OH group. There. We're done with the naming of a butane 1, 4 butanediol of a butane 1,4-diol. Let's go on to the next example. And I want you to pause and try to figure out what is an ene functional group is. And there's a prefix tri here. And if you want to know where you can find the list of these names, you can find them right here, right? And the way to read this particular thing is pretty straightforward. So if we have an alkane, you will have a name with an ending of ane. If you have a double bond, alkene, it would end with an ene, and so on and so forth. All right, so let's go back to the previous example, and I do want you to pause it and see whether you can get the same answer that I do. So again, your goal is trying to draw a hexa 1, 3, 5 triene. Alright, so hopefully you figure out your answer. So hexa means that the longest carbon chain that I have is 6. So I'm just going to draw for now. 1, 2, 3, 4, 5, 6. I have a tri, that means I have 3 of something. And I have 3 of a functional group that ends with an ene. So I have 3 alkene. And they're located in position 1, 3, and 5. So I have 1, 2, 3, 4, 5, 6. And in position number 1, I have a double bond, which is an alkene, is a double bond. Position number 3, I have a double bond, and position number 5. So this is a hexa 1,3,5 triene. Have a structure that looks like that. Now, the next one here is we're going to learn about side chains. Not only that we can have a molecule that have functional group like this or like that. So for example, this particular molecule is going to be called an oct-6-ene. So this is position number 1, 2, 3, 4, 5, 6, 7, 8. So in position number 1, I have an alcohol functional group, so it ends with 1-O. And in position number 6, I have an alkene. So the name of this particular molecule is called oct-6-ene-1-O. Okay. So what happened if we were to have a very similar structure? You can see that the structure on the top and the structure on the bottom is very similar. But now I have carbon molecule, and let me kind of draw this for clarity on the top here. Here I have a carbon molecule and also have a carbon molecule there. Specifically, there's 1 carbon chain long here. So specifically, this is a CH3 molecule. So we're going to call this thing, instead of, if you have a CH4 molecule, it's called a methane. This is our natural gas. But a methyl, if this is a CH3 molecule that is binded to another carbon molecule, we're going to call it a methyl with a YL at the end. So again, this thing is going to be called a methyl. You see, what I want you to know is that if we have a bunch of functional groups, we're going to put it at the end, and it's basically going to be the last name. And essentially, all molecule that looks like this will have a very similar last name to it. But if you have a bunch of carbon molecules attached to it, they're going to have a slightly different name. So if there's a carbon or a methyl group here attached here and another methyl group attached on this side, the name is going to be slightly different. And all we have to do is figure out where it's located. So here I have 2 methyl group attached to it, and specifically we have to know where their location is again. So this is 1, 2, 3, 4, 5, 6, 7, 8. So what I want you to notice is that this methyl is located in position number 3 and position number 7. Yeah. So this particular molecule is now going to be called, oops, I just kind of erased the methyl group there. So specifically I'm going to erase everything else, just 3 and 7 for clarity. So I have 2 methyl group in position 3 and position 7. So how do we add the name to this particular structure? Well, we simply have to add a 3, 7 to denote the location, dash, dimethyl. There. So this particular molecule, now that we have 2 methyl group attached in position 3 and 7, is going to be called a 3, 7 dimethyl oct-16 1-ol. I know it becomes more complicated, but it's actually not that hard to do. It's just addition between one to the next to the next. Okay, let's do a few more examples. Oh, by the way, we can also have attachments that are longer than 1 carbon chain long. So notice these are 2 carbon chain long. So 1, 2, 1, 2. So if you have a 2 carbon chain long molecule, is going to be called an ethane. So these are not going to be called an ethane, but they're going to be called an ethyl. Again, if the carbon molecule is attached to it, it's going to have a YL sound at the end, so it's an ethyl group. Let's do some more example. Instead of from the structure into a name, let's do something like this. So I have now a 3-methyl butane 1-ol. So how do we draw the particular molecule here? The first thing first is you want to know what the last name or the functional groups of the longest carbon chain. And the longest carbon chain is going to be this molecule here at the end, butane 1-ol. So I know that it's going to have 4 carbon chain long from butane. So butane is 4. Ol is going to be alcohol. And it's going to be a 1-ol. It means that it's an alcohol position 1. So I have 1, 2, 3, 4. So 1, 2, 3, 4. And in position number 1, I have an alcohol functional group. And in position 3, this is my first name, in position number 3, I have a methyl functional group. So in position 3, I'm just going to highlight number 3, which is right there. I have a methyl group there. So this is the skeletal structure of a 3-methyl butane 1-ol. In position number 1, I have an alcohol, and in position number 3, I have a methyl functional group. Okay, let's do the next one. Let's do the naming of 2-methyl -1, 3, 5 trinitrobenzene. I didn't mention this before, but nitro is NO2 functional group. And this is, by the way, it's TNT. So let's try to draw the structure here. of TNT. So it's 2-methyl-1,3,5-trinitrobenzene. And because benzene is a cyclic molecule, so this is an aromatic, it doesn't really matter where we start number 1 because they're circular. So I'm just going to start number 1 for my convenient right here. So I'm in position number 1, I have trinitro, so I have 3 nitro functional group. So this is going to be an NO2. So number 1. And in number 2, I have a methyl. Number 3, I have another nitro group. And in position number 4, 5, I have another nitro group. There. Okay. So this is the structure of TNT, or trinitrobenzene. 2-methyl-1,3,5-trinitrobenzene. Let's do one last example and I'll close the video for you guys. The last example that I have here is, oops, there's a typo here in terms of the name. There's a typo here, and this last example, I want to go beyond 10 carbon molecules. So you already know that if it's a decane, is going to be 10, an octadecane, simply going to be decane, which is 10, octa is 8, so it's going to be simply 18 carbon chain long. So I want you to know that, there's molecule longer than 10, and the naming of it, while kind of addition memorization, is not that too challenging either. I don't want you to memorize beyond 10, but I wanted to show that you can have more than 10. So here, the longest carbon chain is octadecane. So I have 18 carbon chain long. So that's the first thing that I'm going to draw. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Once you have a really long carbon chain, it's a good idea to just start numbering it. And here I have a functional group of 1,12 dibromo. So position number, I have 2 bromo, which is basically a bromine molecule, attached in position 12 and 9. So I'm just going to count my number here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. I have a Br here. 10, 11, 12. I have another bromine molecule there. So this is the structure of 9,12 dibromo octadecane. Just kind of an example of things beyond 10, as well as halogenated molecules as well. Alright, so this is it in terms of the nomenclature, and when we come back in, I'm just going to explain how to write, instead of name into structure, we're going to go the other way around. That is, if I were to give you structure, how can you go and write the name for it?